Very good morning. Let us continue what we have left in last class from that part. So today also we will discuss statistical approaches to model building, and we will start with the multivariate modeling. We'll continue with that, and I'll show you many examples of multivariate modeling. There will be some cases that will be discussed, and the cases are important because you know that where these multivariate statistical models are used, and these cases are not exhaustive enough. These are some I can say examples. So you, depending on your area, you have to find the cases where you want to use multivariate statistical models.
Before that, because we will try to cover so many models, it may not be possible to cover all, but substantial number will be of models will be covered here. But before that, what the basics of multivariate statistics is very important, that will be covered. So as far as the sequence of lecture is concerned, so after this next lecture we will be covering your univariate statistics, a few lectures on univariate statistics, followed by multivariate statistics. Okay. So there may be few hours, let it be 4 hours or 5 hours, 4 to 5 hours of this univariate case, then multivariate statistics may be around 7 to 10 hours will be on multivariate statistics, and understanding of multivariate statistics is very important for all of us. Otherwise, you will not be able to explain the multivariate models. What are those models? Why where from these models are coming? What is the utility of model? We will say many things and you will not be able to explain. So the backbone for all those multivariate models, what I have shown you just few minutes back, is multivariate statistics. Under multivariate statistics, there will be multivariate normal distribution, multivariate normal distribution, which we will be denoting like MND, and followed by that will be multivariate descriptive statistics, which covers primarily mean vector, covariance matrix, correlation matrix. So under multivariate descriptive statistics, we will be concentrating on this. Then under multivariate statistics, the next issue is multivariate inferential statistics. Okay. So under multivariate inferential statistics, what are the things we will be covering? We will be covering, first is Hotelling T-square. Getting me? Hotelling T-square, then your that is confidence region and simultaneous confidence interval, confidence intervals, then your hypothesis testing. So whatever you have learned in univariate statistics, that univariate inferential statistics, that counterpart in multivariate domain, that will be discussed up to hypothesis testing. Okay. And that in case of one population, in case of two population, all those things will be discussed there. And you will see later on that, as I told you, that your multivariate normal distribution is the crux of the matter. So, univariate normal distribution all of you know, and that we will denote it like this: n mu and sigma square, where mu is the population mean, that population is characterized by one variable, that is x, and sigma square is the variance component, variance of the population with respect to x, and this one is 1 by square root of 2 pi of sigma square e to the power minus half x minus mu by sigma square, where your this x value lies minus infinity to plus infinity. Okay, it is visible. So, now what will be the multivariate counterpart of this? Multivariate counterpart of this, so normal distribution if you draw, you will be finding like this. This is your univariate normal distribution, which is known as probability density function, or other way we say f x. This direction, x axis will be x variable and your y axis will be your f x. So, you have to understand its multivariate counterpart, that will be very difficult one, it is not that easy. Suppose there are two variables x1 and x2, and then there will be joint distribution x1 and x2. So, what is the distribution? So, something like this, you will be getting a two dimensional picture. When we talk about only two variables, when we talk about more than two variables, picture that is not possible to draw, but you have to think that there is some shape. So, that abstraction level of thinking is required for understanding multivariate normal distribution. And as I told you that multivariate normal distribution is very important, because all the models, almost all the models in multivariate statistical modeling subject follows multivariate normal distribution, because if the data follows multivariate normal distribution, then what will happen, most of the test can be possible. You can measure the goodness of it with appropriate statistical distributions of the statistics what will be used in those models. Okay. So, you will know all those things, that mean vector, covariance matrix and correlation matrix like this. Now, with respect to this small company data, I think I have given you that the data is 12 into how many 6, 12 into 6 data was given. So, you have seen that the matrix also you have seen the data matrix. Now, if I ask you what will be the distribution of this, as there are 6 variables, getting me. So, it will be a 6 dimensional issue, and your joint distribution will be f x1 x2 to x6. So, how to get this distribution? So, you cannot work now in scalar domain like the univariate case, we have to go to the matrix domain, and as a result you will see that I have written under multivariate descriptive statistics few things. One is your mean vector, is coming into consideration. Second one is covariance matrix, third one is correlation matrix. Okay. So, we will be discussing this after univariate statistics. Once this will come, multivariate normal distribution and descriptive statistics is covered, we will go for multivariate inferential statistics, which we will basically discuss on the basis of Hotelling T square. We will be using extensively the Hotelling T square distribution. So, apart from this, I request all of you to do one more thing, that you please go through probability distributions. Little bit of this, because this knowledge is very very important, all discrete and continuous as well as continuous. Because probability distribution will not be taught here. Okay, I will definitely bring some probability distributions, but I cannot explain each of the distribution. Okay. So, you have to go through this. Another issue in this subject is that statistical distribution, no, not statistical, sorry, that is sampling distribution. It is also a probability distribution, but it is related to a, that is probability distribution of statistics, probability distribution of, suppose one is a probability distribution of statistic, 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 or there will be statistics also, but actually statistic and these statistics, by statistics we are basically talking about a random variable. I will explain in a univariate as well as multivariate based statistics case, that how this, what is the statistics, how it is a random variable, all those things will be discussed to you. Okay. Now, let us come back to this again, the introduction part, that I told you that multivariate analysis is purely for the, here for this particular subject here, it is for the practice people who will be using it for solving the real life problems. Now, by real life problems, what do we mean? Here are some illustrative examples. Quality control. Any idea about quality control? For example, you think that suppose in any Kharagpur area itself there is Tata bearings, there is Tata metallics. Now, Tata bearing will produce the ball bearings, roller bearings, this component they produce. Now, this component has certain quality features, for example, the dimensions, for example, the strength. Now, customers require the bearings, the product with certain quality features. These quality features basically converted into specifications. If you produce beyond specification, means not within the specification provided by the customer, what will happen? That product will be rejected by the customers. But if you want to see that why you are producing rejects, then you will find out that there is a problem with the process, manufacturing process. Now, manufacturing process variables will affect the product quality. So, it is the product quality variables will be the dependent side and process variables will be the independent side. You can model that product quality vis-a-vis process variables. Enormous examples of quality control issues are there published in the literature, okay, using statistical techniques. Second example, basically it is a service, one hotel room service case, service example. Suppose you see that that storage, that hotels are there, big hotels basically I am talking about. This hotel, they are basically providing service to many customers. So, now they also require some sorts of service quality management, otherwise impossible, because they will not yield to the profit they are interested in. So, there also lot of data is generated and you have to use those data and develop model and solve the purpose for which the model is developed, or the basically the hotel room service can be much better. Taste of medicine, another issue. Test of medicine means every time, every month you will see that there is a different medicine coming for different diseases. For every single disease there may be 4 or 5 medicines are there. Now my question is, how do I know that medicine works? Medicine A works for some group, medicine B may work for some other group, even though the same disease, or some medicine are performing better than the other medicine for the same disease. So that type of testing is also possible using, if you collect proper data, it is possible. Now vendor selection, it is a very tricky problem, very essential critical problem in almost all small, medium, large enterprises, because your vendor, the supplier's quality is very important. If you get poor items, poor raw materials supplied by your vendor, ultimately your product quality will suffer. So how to go about it? What modeling can be possible there so that you will select the best vendor? There are different ways of selection. Maybe someone may go for not statistical route, some other route, but statistics also, multivariate statistics also helps you in selecting vendor. Safety management. So as I told you job stress few minutes back, there are many variables affecting the people's safety. I want to know that what are the variables affecting more and what are the variables affecting less, so that I can take appropriate actions which will improve the overall safety standards of the plant, of the shop floor, of the work, everywhere. Now lean production. You see this lean production. Lean production means what is basically there. Suppose inventory control is a big issue. You are producing 10 items, but from raw material side you are keeping huge raw materials in inventory. It is a loss to the company. So what you want? You want to minimize the inventory, but you cannot minimize inventory unless you have some steps taken, some buffer or something else is there through which you can satisfy the customer at the same time based on your product requirement, production requirements. Now lean production says that you minimize everything in such a manner that you will satisfy the customer, but as well as from inventory point of view they are also at the minimum level. Raw material inventory, work in process inventory, everything will be at the minimum level. There are very good models in our operation research area, but statistics also can be useful there. Now damage during transportation, another one. You see that damage during transportation, it is a logistic problem. I will show you some, I think one tutorial I will give you later on, that how to model that damage part with respect to that what mode of transport you are using, what is the distance you are transporting, what type of packaging system you are using. So all those things ultimately lead to damage, and it is a huge cost to the company, those who are basically supplying that product to the customers. Effectiveness of training. There is now question is that whether PPT based training teaching is best or class blackboard chalk and talk. There is question like that in the training in the industry level, that whether it is basically classroom training or on shop floor training, what will be the teachers combination, faculty combination. So many issues are there. So if you collect data effectively, you will be able to use multivariate statistical models to find out that which mode of training or which type of training is better. Marketing is an area where your statistics is used very much. For example, if you go through any marketing journal, you will be finding out that full of statistics. Many models comes from that side also. Marketing research, that is the area where you will be able to use statistics. By marketing performance, basically we have conducted one study to understand the purchase intention of customers, and we have used structural equation modeling there. Getting me? Structural equation modeling there. So, some illustrative examples, some other illustrative examples can be framed, but you are the person who knows your system, and please find out some case, some example from your workplace, your domain of expertise, so that whatever I will teach here, you will be able to translate to your own system. In administrative science, management science, social science, everywhere this multivariate statistics is used, and you have to find out all those things, and I will be giving one after another, and you just based on this my explanation and the things you will be learning here, you try to find out analogy to your system and develop accordingly, and then the learning will be complete. Otherwise, learning will become incomplete. You have to be very, very careful for this purpose. I will show you later on some cases, so that you understand that the totality, as I told you, that starting from practical problem to practical solution, that means practical problem, statistical solution, practical solutions. This total cycle will be completed using these our cases. This is first case is characteristics of accident involved and non-involved workers working in an underground coal mine. I told you that in safety management, I told you that one, that in safety management one of the issue is, one of the theories was there, which is not now that much popular, but the theory is still working in that sense, that some people are inherently accident prone. Irrespective of the situation, they meet an accident, but some people are able to avoid accident. So, that is the issue, and then we started thinking that whether that people can be categorized as accident prone or not accident prone. Okay. So, there are 22 variables we have collected, and I will show you this case wherever it is required based on the need of the model that will be described. Then study of process quality, process variables as well as quality characteristics in a cast iron melting process, that is also a real case study like earlier one, that where we have that two sets of variables we considered, and we found out the relationship between the two sets, and based on this relationship how effectively the quality of melting process can be improved. Third one is job stress assessment for industrial workers. Okay. So, there are from officers to that shop floor, maybe your worker like mechanic or the someone who is doing welding. So, different job profiles are there, their responsibilities and roles vary, and accordingly what happened, they may suffer from different level of job stress. Okay. So, I will show you in that how the job profile as well as their demographic variables will affect the job stress, and you will see that what way it will be done, and the similar situation you will face in your work also. Then you will be able to just straightway translate this to your work. It is possible. Getting me? Any question? Because this is a purely qualitative one lecture, and but next class onwards it will be mathematical. and if you there are some I think you know, all of you know this, but there are some famous quotes for statistics. I will end today's now this lecture with these quotes. You know George Bernard Shaw. He basically said, you see, it is the mark of a truly intelligent person to be moved by statistics. Okay. Now you know Mark Twain also. But what he says, there are lies, damned lies and statistics. The two different philosophy. Mark Twain is saying that don't believe in statistics, because statistics is the maximum liar, and at that level. But we believe in Edward Deming's, because ultimately Edward Deming is the quality guru, that sense. He used statistics in the quality domain, quality management domain, and he showed that the statistics can do wonderful in improving quality in terms of totality of quality management. What he said, in God we trust, all other must bring data. If there is no data, I will not believe. Okay. So, what we can then summarize what you have learned today. So, today ultimately we started with, first is the definition of the word multivariate. Then we said that how statistical modeling will be useful. And we also said that when we talk about multivariate, that multivariate observations needs to be carefully measured. You require careful measurement of multivariate observations, and you must be thorough about the data types like nominal data, your ordinal data, your interval data, your ratio data. If possible, you go by this order, means if possible collect ratio data. And we have seen also that ratio data and interval data are basically these two comes under this continuous, and first two come under discrete. But by discrete data we also mean, we understand also count data, that all please keep in mind. Okay. Then I show you basically that that multivariate analysis means you have to work in the domain of matrix, because x n cross p, that is what is our multivariate observation. And this one can be written like this, and there may be several your vectors like x1, like x2, like xp, where x1 denotes the first column all observations, x2 denote the second column of observation, these are the vector variable vector 1, variable vector 2, variable vector 3, that is very important for all of us. Okay. Then another thing what we said, that do not rely on technique, do not be biased with techniques. You go by problem, go by the need of the, by the need means what I mean to say, go by the problem, and you carefully define this, and that definition. So, that means you are basically going from practical problem to statistical problem, to statistical solution, statistical solution to practical solution, then practical solution to this. And what you have understood here also, that you have understood that there are in multivariate models there are two sets of modeling techniques. One is dependence, another one is interdependence. Correct. But please keep in mind that these two will not be fully understood if you do not understand multivariate statistics, mainly the descriptive statistic part. Three things you have to understand here. These three things are multivariate normal distribution, descriptive statistics and inferential statistics. Okay. And last, but that is also very important one, is that prerequisite. Your prerequisite is basic statistics and I think linear algebra, that will be better. Okay. So, thank you very much.